Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purview to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
And this week we're going to talk about digitization of data. We're talking about the hub and spoke method. And that's kind of, how we're going for, the unified namespace type of stuff. So when you start hearing about this stuff, Ed, what are you kind of thinking?
So for me, it's always from a point of view from the OT side. And from the OT side, we have a lot of process signals out on the floor. And to be able to take those process signals and digitize those process signals and populate those into a unified namespace so that each layer of the automation stack has access to that data, and each layer of that automation stack can utilize that data at their layer. And then you can take all of these things as a whole, and what it does is takes the paper out of the environment, takes the human out of the environment. It cuts down on mistakes, and your errors go down.
Yeah, and also when you start thinking about it, you can start thinking about the unified namespace, the UNS, as the information highway. Where do I want to go, and where am I getting off at? Better known as the hub and spoke. When you start thinking about that, you think back to when we did the episode about MQTT and IoT and versus IoT. And this is where we kind of pull them all together and, spit out the data at the end. Because what the hub and spoke method is for the UNS, better known as an MQTT broker, is data comes in off a certain path. It follows the highway down and gets off at its exit, pops off and off to, grandma's house it goes. Depending on what system you're setting up to. Mind you, either the ERP, an MES, or machine learning or anything like that. It's pulling it off there. It's taking that exit and it's heading down the road. From an IT standpoint, and when we set all this stuff up, everything's set up in the configuration. But the thing is then your line side equipment, or depending on what you're using, your edge equipment that you have coming in, or known as your MQTT edge applications, are sending the data over via an XML to the MQTT, and then from the MQTT to its final destination, be it storage or whatnot, how you want to look at it later.
And so when we talk about process signals, we're talking about current, we're talking about RPMs, we're talking about levels, fluid levels. We're talking about things that normally a gauge has to be implemented, or normally someone has to go and physically look at this. With digitization, what happens, or what you gain by populating all these process values from analog into digital into a unified namespace, it gives you the ability at the SCADA level to set up alarming. It gives you ability at the MES level for scheduling. And it gives you the ability at the ERP level for just in time. All these things can work together by looking at all these signals that are modified or converted from an analog signal into digital. And like I said before, we don't want to take the human out of the process. We just want to take the human out of the mundane process. We want to have the human look at the data. The human shouldn't be collecting the data. This should be a paperless transformation. We should be going away from writing down things on a notepad to, hey, this data is automatically being pulled from this sensor, or it's being pulled from this motor, or it's being pulled from this reservoir. All these things are being populated to this unified namespace so that each layer of the automation stack can utilize it as they need it.
So you're telling me you don't want to go look at steam gauges anymore, huh?
Yeah.
Yeah, we want to move away from that. And, the big thing is with that, we want to take like your IoT data, take that data and spit it off the sensors through an MQTT interface from the edge devices into a broker, and from there off to something else. If you think about it, if I pull all that data in, like what Ed was talking about, your edge data and stuff like that, and I throw it into machine learning, now I can kind of tell you, hey, when is this piece of equipment going to fail? When could it fail? That's when we get back and we start talking about, the virtualization that we were talking about and the data visualization topics we were talking about prior. Now we're bringing it all together, and that's just not because, cool, we've entered the realm of, unified namespace, but we've entered the realm of hub and spoke data. It must go around the circle. It's kind of like the wheels of your car. But, we go back to the highway methodology of, I'm going to take my data down the highway, get off an exit, and turn and throw it onto a board so you can see what's going on and when something could possibly fail. And also, if you need to move quality data from one system to another, the best way to do it is through the hub and spoke.
And another good reason for utilizing this type of technology is that the oil industry is already using this technology. They have data for over 40 years of pressures from when they're drilling down into the earth or into inside the ocean to locate oil or whatever. Not that it's the same thing, but now I can build up a histogram over the whole life of a plant, or over the whole life of a cell, or over the whole life of a product model. And then I can take that and use it the next time that I have to commission another plant. And I have all the things that tell me, well, hey, this application is susceptible to these type of problems. This sensor had a high failure rate. This motor had a high failure rate. So with all those things, you can build up a histogram over time by taking all of these signals that right now are just out in the field, not being utilized. But if we digitize those things, we can take that data, like I said, in a unified namespace, using JSON, for example, setting up a template to say, hey, this is how we want our template to be for everything that comes in a unified namespace, because the PLC HMI has its own tags. The SCADA system has its own tags. The MES has its own tags, and the ERP has its own language. And if you're using SAP, that's another layer on top of that. So then you also have your warehouse management systems. You also have your CMMSs. So all of this data can be used in a digitization form in a unified namespace and sent back to, say, the CMMS system, and then it tells them, hey, we need to do a PM on this particular motor. It's time. We're seeing high current. Hey, this robot is having an issue with this joint. We need to lubricate it, and so forth.
Yeah, and also with all that data that you're talking about, we can always take that and throw that into a historian database. That we can go back and look at later, or make graphs of and stuff like that. But it's something that we can store for long periods of time, and at that point, it's time stamped. You know when this data happened because you know when it arrived. You know when it was, and the thing is the arrival time is always set off the machine that sent it. So you have machine-to-machine communication, but you also have machine-to-historian database communication, and then you have your machine learning and other types of, what is it? The Windows system now.
Azure.
Like Azure, or any type of like smart systems that you guys got, can read from the historian database, and it's just an easier way to catalog data and go back and see it later.
And another aspect that's also, I would say, a benefit is that not only when we use this digitization of these signals at the PLC HMI level, we can also use all of these data points over this in the unified namespace, and then that could be implemented or imported into our digital twin. So, for example, I'm ready to commission another line. These data points could be given to an analytical system, and the analytical system can go ahead and calculate risk. And then we would have a risk assessment ahead of time, and then we wouldn't make the same mistakes we made before.
Yeah. It's test before you go live. And, the same thing goes for software, software testing and stuff like that. But having data points and, failure points to be able to test off of, knowing that there's a high likelihood or a low likelihood of this happening if we put the technology or the equipment into this type of scenario. And it's also a way that you can take data, especially if you come out with the historian database, your MES system, ERPs or whatever, you can take that data and actually send it to your suppliers and have those suppliers use that data to make a better piece of equipment, because it knows what the failure rate is based off the data that you already have collected. And it kind of makes not just your life easier, but it makes everybody else's life just that much easier, because you're preventing issues from happening later. And if you have the data coming off of your sensors and through, different IT systems, be it, MQTT or OPC-UA, or coming from OPC-UA to MQTT, it just really kind of depends on how you want to get there.
And then the other thing is each of these layers have specialized systems, and it's very expensive. Anytime you want to make a change without using a unified namespace, you have to change tags. You have to pay engineer at each level, and all suppliers are not knowledgeable in each of these areas. They're knowledgeable in some of the areas, so that's another benefit, because it's scalable. And what that means is it saves you money. And then another thing, we want to be predictive and not calendar-based maintenance. So what that means is it's the difference between the Magic 8 Ball and a seismograph. You're going to use the Magic 8 Ball to tell me when the volcano will erupt, or you're going to use a seismograph. So you have to use the right tool for the right application. If the only tool you have is a hammer, then every problem is a nail.
Yeah. And the thing is, it's also when you're taking this data that you're coming from the floor and you're configuring your systems to send this, especially since most times when you're kind of talking about going from the floor to a subsystem or something like that, it's going to be the MQTT protocol. We know that. 99.9% of the time it's going to be the MQTT protocol this day and age. Make sure that when you're doing that, all your topics and payloads are configured. Because if you accidentally name something wrong, it's going to go to the wrong location, meaning you can't find it later. Come up with a naming solution. I think that's really the big thing. Especially when you're talking about cataloging data and you're pulling data off of, edge devices and having that sent to you via the MQTT clients to the brokers, from the brokers to a subsystem. You have to have the topics and the payloads. The payload is the message itself that's being sent from the device. So my topic, if you're talking about, say, what is it? Say your laundry's done, right? All right, so your topic is going to be laundry. However, your payload is going to be your laundry is done. And then it's going to have your timestamp. So it would go through from the client to the broker, from the broker to your database. And inside your database, it would say, my topic is laundry. But what was written in there, your laundry is done. And then it would throw you a timestamp. So you know the exact time that your laundry got done. Now, if you're talking about like automated tip changes, for instance, or stuff like that on a production line, you're talking about, what's my topic? Well, it's be the robot name or whatever else it is, the piece of equipment, and then the error message or the status message underneath that, and then the time, so you can always go back and reference the three.
And then when you're using PDM, which is predictive maintenance, especially with digitization and using a unified namespace, you can use this to minimize unexpected breakdowns, asset uptime. Reduce operational costs. We can maximize production hours, improve safety, streamline maintenance costs. So we can take these data points and install conditioning monitor sensors with real-time performance data and machine health data. Then use IoT technology, then predictive data models. All these things can be used, and then this can be hand off to the next level, to the MES system, where we can use OEE, which is the most important thing in any factory. And then now we can go and now we can go and rely on the ERP system to do GIT just in time.
Yeah. And as also you talk about just in sequence. If you're talking about parts getting the line and stuff like that based on what you need. And with that, if you think about it, if I have an error message pop up on a piece of equipment, I've now sent that data to an ERP system or whatever. It automatically creates your work order and automatically tells a worker to pick that repair part and go back down there and fix it. So now you're already one step ahead. You're already stepping in front of where you were before. And then the one thing is, this type of unified namespace and the hub and spoke methodology that we use is also something that can help with that, dreaded 3-letter acronym known as KPI. It helps you find what you need. It gives you your data to the people. It pulls your data from the floor and creates that. It's also part of, what we kind of touched on once before, which is Industry 4.0. Unified Namespace and MQTT, for that instance, is part of Industry 4.0 and always will be as we grow forward. We're not going back. MQTT has been around for decades. So Unified Namespace has been around for decades. It's finally now being, taken in to the industrial age and saying that we actually should probably use it now.
Yeah, and then like I said, for me, I always view things from an OT perspective, operational technology. When we're talking predictive maintenance workflow, we're looking at two things basically: a list of assets for predictive maintenance and initial predictive models. Things like CMMS data, asset history, seasonal data, maintenance records, FEMA, and RCM. And basically what we're looking at, asset is running. We analyze incoming data. Asset needs attention. A trigger is alerted. We create a work order. Maintenance perform the work. And then it's signaled back to the system that the asset is running again. These things are all possible with digitization. What you're doing is taking the paper process and a person having to go to each machine, or are we writing something down on a paper, or are we printing out a work order, and we got to manually enter this data. With this system, where we're talking about populating a unified namespace with process signals that are digitalized and put into this space, things like vibration, temperature, pressure, oil, and noise. All these things can be monitored. All these things can be put in a histogram. All these things can be put in a database. All these things can be put in some analytical system. We can use AWS, Azure, or it's a number of things that we can do with this, and have a data scientist at a high level look at it, and then go down to our maintenance engineers, and then they can look at it and see what they can do to make improvements on the floor continuously.
Yeah, don't let what he's saying mean that the maintenance guys out there are going to start getting really lazy. That's not the case. It's not working at. And we're not getting at the fact that we're going to replace maintenance dudes with dudettes with computers. That's not going to happen. You're not going to see R2D2 walk around trying to repair a robot in the next decade. It ain't going to fly. You're not. I'm sorry, but I don't trust a toaster fixing my robot. So if you think about it with that, all we're doing is making the person smarter, giving them more tools, giving them more things that they can work on, and giving them an extra tool in the tool belt, because, you don't want to be relying on the same thing all the time, because it's not always going to work. There's only so many times you can walk around and, make notes about, okay, cool, this thing's running. Oh, look, I looked at the steam gauge and I don't know what my pressure is. There's only so many times you can look at that before you forget. And it's the one time that people forget is the one time something breaks. And the thing is with predictive maintenance coming from the UNS and coming from your edge devices, is something that's there to assist in the execution of the job. It's it's a support function. It's not to do the work, but it's there to support the work.
And indeed, what will actually happen, Nick, is we will eliminate some roles, but we will not eliminate personnel. What'll happen is those roles that were normally wage based and not salary based, or another way of saying hourly, those roles will actually become more of a engineering level. Now you need people that have knowledge of the system to be able to understand what they're looking at. So now I don't have to have a person manually go out and write this data, collect this data, and so forth. Now I can have a guy that's analyze the data. And what we're looking at is like, say for a simple example. So we want to acquire data, we want to process the data, we want to develop a direction or predictive model, and then deploy and integrate this. And that's basically like we generate data from sensor data, then we process the data, we identify conditions and indicators, we train a model, and then again we deploy and integrate this into this digitization, which goes into a unified namespace. I hate to keep beating a unified namespace into the ground, but it's very important. I believe that if we would take the same leap that we did when we went away from somebody manually or somebody having to go to the store to pick up groceries to now they can get on their smart device and order those. The world is already in digitization. It's just industry is not.
Yeah, exactly.
So basically it means paperless.
Yeah. Well, we went from, DOS to, Windows 95, and now we're at Windows 11, but, there's still probably somebody out there, dying of dysentery in the Oregon Trail, but, that's beside the point. But the thing is, utilize the tools at hand, the unified namespace that Ed's pretty much driven in your cranium, that, use those tools to advance, not decrease, but advance what's going on. Because if you don't start doing that now, you're going to fall behind later. And it's always a slippery slope trying to catch back up to what the industry is wanting to do, vice being already ahead of it. And, with that, it's making sure all of your edge systems are available. So all your machine learning systems are there. Your cloud-based solutions are there. Any type of your predictive maintenance and, smart systems are available and ready to go. Before you put a new piece of equipment in or install a new server or something like that, you should have a logging system, kind of like Kibana, like we were talking about the other day, and also attach that to a MQTT interface. And so you can pull that data together so you're prepared and ready to go for what the next adventure is. It's not saying that, be paranoid of the future, as far as how to integrate this data, but it's accepting of it and taking it and turning it into something useful for the people who need it.
And with digitalization and using a unified namespace over the whole automation stack, we want to get to the cloud. And when we think of the cloud, we don't think about hiding up on or cowering on an umbrella. When we think of the cloud, we should be thinking the million possibilities that you can have when you look at a cloud.
Yeah.
So we should be using this cloud technology to innovate, to make our companies more profitable. Because to be honest with you, if you're not using digitalization right now, or if you have no plans to move toward that, quite frankly, you may be in trouble and you may not exist in 5 to 10 years. Yep. Because this is a definitely mandatory and critical thing that you need to do for your plants. Imagine how many millions of dollars are spent over all of the plants in the United States of America on somebody going out and writing something on paper.
Yeah. Or how many times that you've had to replace parts that didn't need to be replaced. How many, if you look in your maintenance cages, same thing for us IT folks. You look at your maintenance cages, you look in your extra spare rooms that you got in your office, you're going to see nothing but junk. Stuff that you don't need anymore. You may not even own that piece of equipment anymore, but guess what? You still have the floppy disk to tell you how to put together. It's one of those things. We've all been there. We've all opened up the box, had 3,000 cables and the darn thing, wondering what the heck am I got this for? You don't want to be stuck in that decade anymore. With this, it's take this technology and run with it, have fun with it, learn it, build it to what you need it to do. Don't fall behind and miss the boat. Always innovate now to save you money in the long run. Because, yeah, if you want to go to the cloud, either on-premise or hybrid cloud or full cloud, hosted by AWS or Azure or somebody like that, you're going to save money in the long run not paying local power bills. So, if you move your entire data center. But you still need to have that data going someplace. If you're collecting data, you're always, one step ahead of where you were yesterday.
And just like the Egyptians used hieroglyphs, and now that's obsolete. It probably was the thing of the time. But right now, ones and zeros are king.
Yeah, we're past the world of sundials. And now you can, you can tell me what your heart rate is by looking at your watch. I'm not having to stay in the sun and determine if it's noon or not. We're well past that, and I really think that this, the unified namespace, the hub and spoke methodology, the MQTT methodology, this all falls into one. MQTT is the oldest unified namespace in the world. So the thing is take that technology and run with it. If you have any questions about this, hopefully, we can probably throw something in your direction if you need it. If we can't find it, we're bound and determined to look it up and, try to help you out, but, the best thing to do is, get behind it, learn it, see what you can do with it, and just innovate with it.
And I was always told that when you see something that works and is proven to work, there is no reason to do something different unless what you have, the derivative of what you have found is much better than what you have. So this is something that's been in place over the last 20 years. It's not some new technology. It doesn't mean that, hey, this is going to fix everything in your company at once. What it means is it's going to streamline your company. What it means is it's going to save you money on resources that you can allocate in other places. Because at the end of the day, data is king.
Data's new oil. Data's new oil, and at this point in time, you got to start mining for it. It's only gonna make you more, productive, streamlined, a little more efficient, and it's gonna cut down your maintenance cost. You're gonna know what's coming. You also have logs to look back on and kind of see what happened. You always want to be, a step above the rest, and understanding your data and how you can go with that is, I think, the way we're heading. And with unified namespace, MQTT, hub and spoke, is probably one of the best ways to get there.
And the other thing I would say, if you have any questions, you can reach out to Nick and myself. We'll be glad to point you in the right direction, offer any guidance and mentoring that you want. But also get out there and learn about these topics, read about them, go to HiveMQ and look into some of these things. IBM is one of the founders of this technology. I mean, learn JSON, get into these things, understand what they do, and then maybe just put it in a virtualization, or maybe just set up a test environment where you can just kind of play with it and see how it would actually be beneficial to your company.
Yeah, 95% of technology is free. It's all how you use it. It makes it expensive. And how far down the rabbit hole you want to go. But, like Ed said, get out there and learn this. Have some fun with it. Play with it at home. You can find stuff at home to do it with. It's have it hooked up to something in your house that tells you when something turned on and off. Especially if you got kids, it's a great thing to do because you can kind of see when your kids let the light on long enough or not. It's just one of those things. Play with it, have fun with it. Learn it, enjoy it, and just be a step above the rest and always keep learning. So with that, we'll let you go. Enjoy the day, and we'll see you next time.
See you later.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.